All right, class. My name is Kevin,
My name is Tim.
and for our project, we built a parking sensor that allows easy access into the tight space of your garage. So for our problem, currently there are many people who are still struggling with parking in tight spaces and even their home garage. It is likely for accidents to happen in these tight garages, and not everyone drives a newly advanced vehicles that may have parking sensors included. And if an accident does happen in the garage, repairs for a new bumper could be very costly, ranging from hundreds to thousands of dollars.
So after brainstorming, we came up with an idea to use the Arduino ultrasonic sensor, which was included in our class kit as our parking sensor. As you can see in figure 2, the ultrasonic sensor will emit sound waves at a frequency that are too high for humans to hear. The sensor then waits for the sound to be reflected back from the front bumper of the car, calculating distance based on the time the reflected waves come back. This is similar to how a radar works by measuring the time it takes for a radio wave to return after hitting an object.
So following the ultrasonic sensor, we have these other materials that we needed to design this project. Most of the materials came straight out of our Arduino Uno starter kit. These items would be the Arduino jumper wires, male to female jumper wires, and the Arduino breadboard. The item we had to buy was the RGB LED ring lamp. Other than that, we had an external power laying around the house and decided to use it to power our device.
So to give our device a simple and clean look, we decided to get a mount that was 3D printed so that it would hold the ultrasonic sensor and keep it in place. Keeping the sensor in place will allow it to be more consistent when reading the approaching vehicle in the garage. Kevin and I had to measure out how we wanted the dimensions to be for the mount, and we had to measure it so that the ultrasonic sensor would sit nice and snug inside, as seen in the pictures on the slide. Also, this mount allowed us to hide all of the wiring, which can be seen here on the next slide.
All right, so here we have our wiring. Um, this is for the parking sensor. And then also thanks to the help of Tim, as seen on figure 6, he actually soldered on the jumper cables onto the LED ring. And this mount, oh, and after all the wiring, we had to make the code on Arduino so that it would coordinate with all the wiring on the breadboard and the Arduino Uno board.
So here in figure 7 is the code that we used. We wanted to make sure that the distances were right for parking the car in the garage. So we used if and else statements to make sure that the LED will light green when it's over 6.5 feet. Between 3 to 5 feet, the LEDs will be yellow, and between 1.5 to 3 feet, the LEDs will shine red. For the driver to know when to stop, they would have to go closer than 1.5 feet, and the light will start flashing red.
Okay. So here we have our design on figure 9. So this was our initial design before we had everything, all of our materials delivered to us. And then on figure 10, this is actually our final product. It came out pretty similar in the end. And as you can see, we decided to use some boxes so that the parking sensor would have a stable stand, and then that the LED ring on top would stand tall so that would be visible to the driver.
So here are videos of the actual parking sensor in action. So as you can see, Kevin is approaching the parking sensor. Right now it's turning green. As he gets closer, it will turn yellow. Now it's red. and then flashing red. Another point of view.
And then for the team contribution, we split up the workload pretty evenly, 50-50. And then my jobs were to work on the sensor design, install the hardware, and work on the PowerPoint. Tim's jobs were to work on the software, test and debug the device, and work on the PowerPoint as well. All right, so here we have our survey questions, which had a total of 20 people that responded. For the first question, do you drive an automobile? 90% of them said yes. And then for the second question, do you park in a garage and or in tight spaces at home? And a majority of them said yes, meaning that they would be interested in a parking sensor. And okay, for the next two questions, we have how often do you park in tight spaces? So a majority of them said always and sometimes, and then some of them just said rarely. And then for the fourth one, have you ever had trouble parking in these tight spaces? Most of them said yes. So these two questions gauges the audience to think about how helpful the parking sensor could be, since the majority of these people responded that they park in tight spaces often, but may have some trouble doing it as well. And then for our last few questions, would you be interested in a device that helps you park in tight spaces? So actually all 20 of them said yes to that question. And then for the fourth one, how much would you be willing to spend on this device? Most of them was trying to go around the $10 to $20 range. But we ended up using around $50 plus for this device.
So this was our part chart. This was our part chart. We just started off with researching on how to make the parking sensor. We designed the sensor, and then we started ordering parts and started making the sensor. This is our Gantt chart. The project idea took a little longer than we expected. We were still confused on what to do during the beginning of the class. Our design was 2 days over, and our testing, or no, sorry, our diagnosing. The sensor was being a little finicky when we were trying to use external power. So we used a battery pack for our phones to power the parking sensor. This is our purchase report. And in conclusion, we had a great time doing this project, and we were successfully able to make a working parking sensor. Although our design wasn't the best, we wish to 3D print more items to make the design cleaner and more simplistic. Also, we could try mounting the LED ring on the wall. That way, it'll be a lot more visible to the driver. We hope you guys enjoyed our presentation. Thank you.